So we have our axes, and remember, X is your horizontal, and Y is your vertical. All right, when we count, we have positive numbers from here over, negative numbers here, positive up top, negative on the bottom. And this point at the center is at 0, 0, and we call it the origin. Cool, cool. All right. This, remember, is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we always write our ordered pairs as X and then Y, right? It's alphabetical. X first, then Y. Horizontal before vertical. When you were a baby, you learned to walk before you learned to jump. So you have to go horizontal before you can go vertical. All right, and then last thing, in our first quadrant, all of our points are positive, positive. And then we have negative, positive, negative, negative, and positive, negative. So far, so good? Please let me know if I'm going too fast ever, because I do talk quickly and write quickly. So once we get to some more notes, sometimes I go too fast. So just let me know. All right, so that's review. Today we are starting our very first unit of Math 8, which is super exciting, okay? So we are going to be talking about transformations. Transformations. Right, and I'm going to give you a definition here. Transformations are the changing of a shape using a turn, flip, slide, or resize. So, changing of a shape using turn, flip, slide, or resize. any point you have questions or anything like that, unmute yourself or put them in the chat box, okay? Okay, so then transformations are a classification of all types of movements, okay? So there's different types we're going to look at. Turns, flips, slides, or resize. 3 of these, whenever you perform them, the shape and the size does not change. So if you have 2 images that are the same size and the same shape, does anyone know what that word we call it is? It starts with a C. When shapes are the same size and the same shape. Nobody? No one? Congruent, right? Remember congruent? Yeah, okay. So transformations that keep the same size and same shape are called rigid transformations. Okay, so keep same size and shape. And the pre-image, is congruent to the image. All right, and then if you want, you can put this, you don't have to. This is our turn, flip, and our slide, okay, are all rigid. And we're going to come up with official names for those, but for right now, those are all our rigid transformations. Sorry, guys, I have a drum set next to me that I just bumped into. Okay, so specifically today, we are going to look at translations. Translations, okay? And these are our slide across the coordinate plane. A slide across the coordinate plane. Okay, so when we're sliding, we can go up and down and left and right, which may appear as diagonal sometimes, but the orientation of the shape will never change. So it won't turn, it won't flip. We're just gonna slide back and forth, up and down, or diagonal, okay? So let's just dive right into a little example. Okay, so it's going to say translate triangle ABC 2 units left and 4 units down. Cool, translating 2 units left and 4 units down. And then we need to know where triangle ABC is, right? So A, B, C. A is at 2, -3. B is at -2, 1. And C is at 0, -6. So go ahead and just graph that triangle on your paper. And label your points. Oops, I'm already wrong. Womp womp. Okay, so when we actually translate this shape, it says we want to go 2 units left and 4 units down. So the whole shape is moving 2 to the left and 4 down. But we don't have to move every single individual point. We can just move like key points. So starting with the points they gave us, if I'm going 2 left and 3 down, or 4 down, I can just count. So starting here, 1, 2 left, and 1, 2, 3 down. Okay, and then we rename that point. So that was B, and then we just moved it, so it becomes B prime. So when you move a shape, you give it 1 prime for each movement, and that tells you how you know from your start to your finish. Okay, so then we do the same thing with A. We go 2 left, 1, 2, and 4 down. 1, 2, 3, 4. And then this point is called A prime. And then we do the same thing with C. 2 left, and then 4 down. And that's our C prime, okay? And then we just connect our dots. And you have your translated image. Go ahead, Asher. You have a question? Okay. So you started here, right? And then we went 2 left and 4 down. So I go left, 1, 2, and then go down 4. Does that clarify? Cool. Good question. Any other questions about that? So let's write down our ordered pairs for A, B, and C prime. So our new image, their new locations. So A is currently at 0, -7. Oh, you need this page? Well, B prime is at -1, 2, 3, 4, -2. I made my thing too little. -4, -2. And C prime is at -2. No, wait. Yeah, -2, -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -10. Those are very little. I'm sorry I wrote them so small. But yes, translations are not that hard, okay? The only thing that we add to this is, so this is, you've performed a translation here. Perfect, beautiful, wonderful. Now, the only other thing we're going to do with translations is write an algebraic rule. Okay, so we're going to write an algebraic rule. When you write algebraic rules, we start always at xy. This tells me I started at xy and I'm going to. Okay, this is just kind of standard for algebraic rules. Now, what did we do to our x value? So compare a to a prime. How did I get 2 to become 0? Do I add or subtract 2 to make it 0? Good, so that means I took my x value and I subtracted 2. Look, that matches a 2 right there. Okay, and then for our y, we started at -3 and we went to -7. So how do I get from -3 to -7? Good, so I have y minus 4. So far, so good? All right, let's try another one. I'm going to turn my page because I'm out of room. If you have more room, you can stay. But if you want, flip your page. And draw another little coordinate plane here. Oh, just threw my marker. And we're going to just do it with points this time, not an entire shape, just so we can kind of get another general idea here. So I'm going to put the point Z at 5, 4. Cool, so this is Z. All right, so on this one, let's go right 2 and down 4. So if I take the point Z and I'm going right 2 spaces and then down 4 spaces. So I just count, right, 1, 2, and then down 1, 2, 3, 4. Gets me right here. And I label it as Z prime, okay? Because that's how I know that that's my new image. And then Z prime is at 7, 0. All right, so what do you notice about this one if we wanted to write a rule? What did we do to X here? Good. How many did we add? Beautiful. Thank you, Kennedy. X plus 2. And then what did we do to Y? Anybody know what we did to Y to get from 4 to 0? Good. Subtract how many? Beautiful. Look at that. You wrote a rule. Let's do one more. So let's have K is at -6, 1. Oops, that's K, not K prime, sorry. Just K. No K prime. Okay, and let's go up 3, right 5. All right, up 3 and right 5. So I'm going to go up 1, 2, 3, and then I'm going to go right 1, 2, 3, 4, 5, and I put my new point, and this is my K prime, and K prime is now at -1, 4. Does anyone think they know the rule for us? Always starts like that. And then what did we do to X? What did we do to X? Don't make me just call on you. I will. Added how many? Good. We said X plus 5. And what did we do to Y? Safiq, do you know what we did to Y? Here's your hint right here. Up 3. Yeah. How many did we add? Yeah. Cool? All right, so that's our rule. So has anyone noticed any trends in our rules here, like about when we add and when we subtract? Any trends about when we add and when we subtract? Eric, can you tell me what happens when I add to X? Which direction I go when I add to X? Asher's giving you a clue. Eric, are you with us? All right, Ariel, can you? All right, Eric. Eric's with us. He says, so Eric, what happens when I add to X? What direction do I go? If you need a hint, look right here. Right here, we added 5 to X. Which part of this told us about the 5? Good. All right, so Eric said we go right. Ariel, can you tell us what happens when we subtract from x? Good, we go left. Caroline, can you tell us what happens? Oh, I wrote that in the wrong place. Burp, burp. Caroline, can you tell us what happens when we add to y? So here's an example of adding to y, and here's an example of subtracting from y, so you can compare. What happens when we add to y, and what happens when we subtract? Do we go up, or do we go down? So adding to y, there's an example right here. What did we do when we added to y right here? Good, we went up. Mike, can you tell us what happens when we subtract from y? When we subtract from y, so there was an example right here. What happened when we subtracted from y? What direction did we go? You're thinking of x. I'm talking y now. Do we go up or do we go down if we subtract? Good. Barbara, do you have a question or are you just going to answer? Oh, okay. All right. So let's do like just two quick little examples in your notes. I want you to just write them and then we'll go over them. So I want you to write a rule, okay? Write a rule. All right, so you're doing these two, and when you have an answer, put them in the chat box for me. So writing, and you can just write them as like, I'll give an example in the chat. You don't have to do the x, you can just say x, like plus 4 or plus 3, y minus, let's do a different one. X plus 9, y plus 2. If you write the rule just like that in the chat box, that's fine. Just how I did. So give me a 1 and a 2 in the chat box and tell me what your answers are.